Hello, everyone, and welcome to today's webinar with Febin Jose and Mr. Joe Pikus. My name is Kesley Price. I am the Product Marketing Manager here at Technical Toolboxes, and I will be facilitating the webinar today. Before we get started here shortly, if you have any questions on what our presenters are covering, there is a chat box on the right-hand side of your webinar interface. Please send us any questions you may have throughout the presentation, and we will do our best to cover all the questions we receive at the end. With that, I will turn it over to Febin, and we will get started. Thank you very much.
Thanks, Kesley. Good morning, everyone, and thanks for joining the call today. We hope, it's a good learning experience to hear more about what Hydrotest is and what the implications are, and hopefully you take away something from this presentation. Thank you. Let's now get started. All right, so quickly, let's look at the agenda for today. What we're going to do here is give a brief background on the hydrotest process and the history on hydrotesting, have an overview on the risk and the regulatory changes that has happened and that's still happening, talk about the importance of the documentation and the TVC principles from the Mega Rule, and then we will move on to a live demo session of the hydrostatic testing tool within the technical toolboxes, and we'll keep the window open for live question and answers if you have anything. So that's what the agenda looks like for today. So hydrotesting has been, the philosophy of hydrotesting has been there from the early 1900s. It's been used in the vessel industry. So hydrotesting from an intro standpoint, as the name hydro says, water-based testing. So it's a method used to perform strength and leak test on the pipeline. So what it does is, you do the test by taking the pipeline out of service. You then fill it with water, raise the internal pressure of the pipe to a designated pressure or a stress level, and then hold the pipe at or above the designated pressure for a prescribed period of time. The prescribed period varies depending on the governing principles from the code standards. Usually the hydrotest is done for both new pipes and the existing pipes. For commissioning of the new pipe, the last major activity that you do before the commission is to get the hydrotesting done to validate the MAOP or MOP, depending on the fluid that's flowing in the pipe. Also, you do the hydrotesting for existing pipe to identify if there is a flow in manufacturing, in the manufacturing of the parts that are used to build the pipe, or it's used if there are some defects that you have found in the fittings and the materials that are used, or it could be that during the design phase, if there is some erroneous, some design flows that was there as part of the construction process that could be also identified using the hydrotest. So there are a wide variety of reasons why you want to do the hydrotesting. Some of them I have listed here. So one of the key reasons that you do a hydrotest is to identify the stability of the pipeline that's in operations, right? So that's one major thing. There could be a scenario where you want to establish or re-establish the MAOP of the pipeline or the MOP of the pipeline. So that's one of the reasons why do you want to do it. Or if you want to essentially requalify the pipe, let's say you have a survey that was done and some of the locations have changed. You need to requalify the pipe and make it fit for operation. So you need to essentially do the hydrotesting to essentially revalidate the MAOP. That's also one reason why you do that. Also, when there are operation specific assessment and safety programs within your company, that's also one governing factor that you do that. These are reasons that mainly you do, but there are other reasons too. Like, there's an acquisition or a merger that came in. There are records and documentations related to the sectioning of the pipe that should be made available. If it's not there, you need to generate the new records to essentially use it for governing reasons. And those are also reasons that would essentially trigger a new hydrotesting for the pipes. So I briefly touched on this, the history of hydrostatic testing. So hydrostatic testing evolved from the vessel testing, the vessel industry prior to 1900. So that's where, I mean, it evolved into. So prior to 1955, what used to happen was, I mean, even though it was called as hydrostatic testing, I mean, the testing was done through fluid that was flowing in the pipe. So then post 1955, what happened was, I mean, the ASME as an org reorganized, and ASME essentially developed the B31.8 code for pressure testing for all pipes that are operating above 30% spice. So that's how the evolution happened. But one thing that was still missing was duration of the test was not specified even after 1955. Here's a history in a timeline perspective that covers what I showed in the previous slide. As you can see, the process of defining the time it takes to essentially do the hydrotesting essentially started after 1970. So as you can see here, so after 1955 is when, I mean, you can see the post-installation pressure testing, and the test duration was not specified during this time. But I mean, after 1970, I mean, it was something that was specified. So that's a brief overview there. Now, this is essentially a test factor specification and the evolution of the test factor specification for minimum test pressure that you want to test the pipe against, and how it has evolved over the period. Right now, currently, I mean, depending on whether you're in gas or liquid, I mean, it's governed by 192 or 195. I have categorically defined this presentation more so to talk about the Mega Rule side, so we will talk more on the 192 side. The CFR subsection of 192.619A2 subpart 2 would essentially cover what is the latest test factor ranges that's tied to the classes that are covered here. The only addition from this chart or from this table that you will find in the latest version is they have included 2 new subcategories or subsections for installation of pipes that have been installed after July 20th, 2020, with the test factor starting at 1.25 for class 1 location. And they have also included a category for conversion of the pipes that have been converted under 192.14. That also goes with the test factor of 1.25. Starting test factor is 1.25 for class 1, and as the class location increases, the test factor locations for the safety concerns also improve dramatically. So what does it say about the minimum test pressure and the control point, right? So the minimum test pressure is basically governed by the CFR codes between 192 and 195. In 192.619, the table clearly covers the test factors and the test factor ranges for different kinds of pipe that are laid with the timeline and the location classes. So that essentially covers that, and that's the governing process. Now, the National Transport Safety Board usually recommends any pipe to be tested at no less than the 1.25 times the maximum allowable operating pressure for class 1 to start off with, so that the safety is introduced and safety is withheld within the industry. So now there is a subcategory within the hydrotest process called as the spike testing. So spike testing is a variation of the hydrotest, usually done in tandem with the hydrotest. The good part of spike test is, I mean, if there's an 8-hour window, you can break or include include spike test as part of the hydrotesting process. So usually done ahead of the full-blown hydrotest that you have. So in the first 2 hours, you might do a spike test based on the specification that's there. So what you do for the spike test is, I mean, you spike the pressure above the minimum test pressure to a prescribed level. And you're doing it for a shorter time frame, and then you essentially reduce it back to the minimum test pressure that you want to test against. So it's essentially spiking it, and this is done for 2 main reasons. One is essentially you want to essentially induce failure in the pipe. I mean, if it's possible to see, I mean, if there are defects, that needs to be attended, and that's one thing that you can do. So the other thing that it allows you to do is, I mean, since you are introducing a higher pressure range, any surviving cracks that could potentially have been a problem could be stabilized. That's also one thing that's done. What the National Safety Board, the National Transport Safety Board essentially recommends incorporating a spike test when testing existing pipes with a test pressure to MAOP range, that's a test pressure range of less than 1.4, and for pipes that usually experience seam weld failures or pipes that are susceptible to seam weld cracking or seam cracks. Those are the places where spike test gives a greater advantage there. There was a PHMSA study that was done, I think it was in 2012 that talks, 2012 or 2014, I'm not so sure about the date, but that essentially covers in detail on the merits of essentially having a spike test introduced into your hydrotest. So if anybody's interested in knowing more, that's a good recommended reference to essentially look more into. So this is something that I pulled up from the PHMSA annual report. It was essentially done to give you context on how the evolution in the industry is happening. So if you look at it, I mean, between in the last decade, in this decade, when you look at anything that's new from 2020 to 2029, there was less than 6,000 miles of new pipeline that was added. So what you are seeing is a mix of pipeline that has been in the that has been laid underground for a longer period, and you're essentially continuously doing the maintenance and the operation and the testing there. So for a simple context, in 2012, 58% of the total gas transmission lines were installed prior to 1970. Yes, I mean, there were repairs happening there and replacement happening, but in 2022, still 54% are still installed prior to 1970. So even though there is a lot of significant improvements in the replacement that's happening, I mean, you are still in a place where hydrotest becomes a important aspect in your safety process, and it's not going away. If there is something that's take away from this slide, it's the emphasis of how important hydrotest is and why it's still going to be an integral part of your integrity specification and integrity process. So there are some risks that's tied with the hydrotest. So we want to break it down to discuss with hydrotest for buried pipeline and exposed pipes. So for buried pipes, the risk is lesser compared to exposed pipe. Exposed pipe, in addition to everything that you see as concerns and problems that comes around with the buried pipe, the additional aspect is, I mean, you are now exposed, which really affects the equipment and the personnel, I mean, who are doing it. So it comes in with this, its own consequences and failure. So a good plan should essentially look at analyzing what are the consequences that are tied to a failure too. So one of the major reasons that's driving a lot of the recent MAOP validations and the hydrotesting is the regulatory changes. Mega Rule, so for anybody that's following, Mega Rule is now finally complete. The Mega Rule 1 was released in October 2019, just followed up with Mega Rule 2, Part 2. It's a three-part rule that was completed, or the study that was completed. The Part 2 was completed in November 2021, and now you have Part 3 that was released in August 24th, 2022. So the important aspect there is bulk of the substantive requirements of the rule is taking effect, has already taken effect later part of last year. So that's one of the reasons why a lot of the MAOP validations and the documentations and the traceability and all aspects of hydrotesting is becoming important in your day-to-day life. One of the major call out in the Mega Rule change is the limitation that's tied to the grandfather clause. For anybody, I mean, who's not familiar with what the grandfather clause is, that was a categorical clause tied to Part 192.619. It's essentially called as the grandfather clause for confirming the MAOP. So what that allowed a lot of the operators to do was to confirm MAOP using the highest pressure test recorded within the 5-year period that predates the July 1st, 1970 pipelines. So what has happened with the regulatory change is you no longer can use the grandfather clause broadly. So it's now applicable to pipes that are operating under 30% spice or pipelines that are operating in class 1 or class 2. So which essentially is one more prompt that is essentially prompting you to just simply do the revalidation for all pipelines that have been previously protected by the grandfather clause. That's one major change that's coming in, and it also is important to essentially see the reformation in the MAOP because some of the geographies are changing, location classes are changing, you are getting new survey data. All those things are essentially forcing you to do more and more revalidation work for your hydro test or for your pipeline. So what are the Mega Rule implications that you should be looking forward to? There is going to be an increase in scrutiny on the documentation and on the traceability, verifiability, and the completeness of the documents that you have. So since, I mean, a lot of us have worked in the industry where consolidation has been part, I mean, one of the things is historical records might not meet the requirement because there could be scenarios where you can't essentially trace the origin of who conducted the test and what sections were completed. I mean, that's one aspect to it. Hydro testing is just one aspect, but there are other aspects in your Mega Rule that forces you to look closely into the traceability of different aspects, the equipments used, the construction materials used, everything has to be traceable now. So that is the Mega Rule implications that you are more so looking forward as we get into the phase of implementing the Mega Rule. For a quick reference, so based on the Mega Rule implementation, by what it's calling for is by July 2028, 50% of all the pipes that haven't been verified needs verification completed, and by 2035, 100% of all the pipes that are in operation should have the MAOP verifications. And so these are some of the call outs from the Mega Rule implementation that you will see more often now. So, so how can you do this process and make sure that, I mean, regulatory handouts are done and you are in compliance, right? So one of the thing is basically looking at the pressure test planning. You need to start, you need to essentially understand what's the reason why a pressure test planning is being conducted and what is it that you want to try to accomplish. I mean, is it that, I mean, you're doing a stress test for the pipe, or is it that you're doing a revalidation for the pipe based on the location class change? All those things play a key role in essentially helping you design an effective hydro test plan that can then be communicated to your contractor or to your engineers, I mean, who are executing this. Documentations can't stress enough on this. Documentations are becoming an important aspect and a concern throughout our industry and throughout operations. There are major concerns on what needs to be covered in the documentations and also a better understanding of what is requested from a regulatory standpoint and what subsequent documentations are required. This requires understanding of the Mega Rules and the code standards. And also, I mean, one thing, at least, I mean, we have observed is standardization greatly helps, and having a standard workflow is something that has helped people, I mean, in the industry to essentially be very compliant with the regulations there. So again, some of the concerns with the documentations that historically people have been complaining about is the change in operatorship and the ownership, and lack of traceability, verifiability, and the completeness of the documentation that's there. Paperwork is missing. These things were okay back then, I mean, but with the implementations and the implications of these regulatory changes, it's going to be scrutinized more. So, so this essentially, these were some of the concerns that we found out as we were studying the roadmap and studying the changes in the code standards and applicability of the Mega Rule. In our understanding of our questions that we asked was, what is it that, I mean, we could help, and how we can have a standardized process to help our engineers work effectively and make sure that these planning can be done with little to no external reference or external reference that's required. So that's essentially where we thought of bringing in a workflow that's user intuitive and that essentially provides a user experience on par that would essentially help you manage and plan your hydrotesting process effectively. So our hydrotest power tool, so when we essentially implemented the hydrotest power tool, the few things that we looked into was we want to essentially help you support your record keeping and traceability, the verifiability, and the compliance piece. So we, with our implementations of the tool within the Hub platform, can essentially help you with your record keeping. Also, I mean, the compliance piece, I mean, we have built the tool to be essentially compliant with both 192 and 195. So whether it's gas or liquid that's flowing in your pipe, we have the tool that essentially would handle that for you. And also the final piece is the documentation piece. So we want to essentially provide a documentation that is that can be easily shared across the different teams, and also something that can be recorded so that anytime when a review is done, there is an easy place or easy source where you can essentially generate it with enough credential details on why the hydrotest was done, who did it, and when it was done. So all those things can be included or tied into the record keeping aspect there. So few advantages from a hydrotesting power tool is we have a workflow that is semi-automated. So depending on what your use case is, whether you want to use an Excel survey file or you want to use it based on ArcGIS map, or you want to do it manually, we have different workflows that essentially helps you do that. It's a semi-automated intuitive workflow. We didn't take the full automated approach because, I mean, at the end of the day, I mean, it's something that's being planned and it requires a very high level of input from the engineers who are designing it. So what we approached it was we want to make sure it's semi-automated in a way, I mean, it's not repetitive, but at the same time, it gives the scrutiny and a vigorous review process that helps the engineers make the right kind of framework to make the hydrotest planning as comprehensive and as easy to execute as possible. That's one aspect. It also brings in the time-saving element by essentially standardizing the process for you. So those are some aspects that we are covering there, and our major goal is essentially to standardize the workflow for you so that whenever you think of hydrotest, I mean, you can use a standard workflow that can essentially be implemented across the org so that everything that comes out of it, standardized workflow that's audited. And we spoke about the report, and this is the report format that you see as part of the hydrotesting report that we generate. And that closes the presentation side of hydrotest. The next aspect that we're going to do is I'm going to share the screen and show you the hydrotest in action live within the Hub platform, give you an overview on what the tool looks like, and maybe even after that, I mean, we will find some time to essentially help answer all the questions that would have come in now. All right, I hope everybody can see my screen. What I have loaded here is a hydrotest, is the hydrotest power tool within the Hub platform. It's in pipeline engineering software, and under the hydraulics, I mean, you have hydrotest, and that's where you have the hydrotest tool here. What we have here is a fully integrated tool that's built in with ArcGIS and the UPDM and the ports database for the data architecture structure, but at the same time, giving you the simplicity to go to how you're doing it right now. If you're somebody, I mean, who has used Excel and who would like to simply use the Excel workflow, we have the same workflow in the manual process. If you're somebody, I mean, who works with the asset data and wants to essentially bring in the asset data and interact with the GIS to essentially bring in the ground elevation and work with that, we have the capability to do that. Or if you're somebody, I mean, who is essentially working with survey data, that's also something that we can do that. So, so on a quick step, this is where, I mean, you define your case and the case detail. What I have here is a predefined demo case that I want to go over so that I can show you the different aspects there. So we are in the summary page or the overview page here right now, where I have done the hydrotest for 5 different sections for my pipeline, as you can see here. So these are the 5 different sections that I did the hydrotest for, and this is the summary outline that actually talks about what's the status on the hydrotesting done for each individual sections, as you can see here. One of the section is failing, and this fail criteria is based on the validation checks that we have already implemented there based on the code standards between whether it's 192 or 195, right? So that is essentially what it is. Now, in the summary, what you see here is the entire asset data or the pipe that's being loaded here, along with the elevation profile for the pipe. But what you see here is from where I have basically started my hydrotesting. Even if you're bringing in an asset data, it doesn't mean that you have to start from the starting point to essentially run this. I have selected an intermediate location where I want to do the hydrotesting for, and that's essentially what you see here. And the section is starting from somewhere in the midst of the pipeline where we want to actively do the hydrotesting, and those are the places where we have done the hydrotest sectioning here. So now, regarding the sectioning, there are different ways we can essentially semi-automatically run the sectioning for you. If you essentially would like the system to identify and define the sectioning for that, that is also something that we can do. If it's something that has to be manually done, we have the capability to do that. Yeah. So what you see here are the section controls, all the features there where if you define your first section and you want to essentially build subsequent sections, you can use the copy feature here to essentially copy the pipe attributes and the pipe configuration data for the subsequent sections. If you are somebody, who thinks, okay, fine, hey, I'm doing the hydrotesting planning, because I have an elevation head, or in this particular case, I'm going into this third section where it's failing to see what is the reason why it's failing here. So the third section, what I see here is what I see here is the input data that I have used for the calculation, and the results tied to that particular section is here. And the warning essentially says there's a test range error because of the maximum allowed elevation differential, and that usually comes in, or the validation check comes in, when there is a pressure difference between the min and max is not sufficiently supported. And in this case, the elevation head is high, and that's the reason why it's essentially asking me to essentially do a subsequent or break down the sections. If those are the kind of scenarios that you would run to, what you can do is, you can essentially use the split feature within our tool to essentially split and say, fine, hey, these are the locations. This is how I would like to split it, and that's also something that we can do within the tool here. So in case, if you are essentially in a place where you want to merge 2 sections to combine it into a single section, that's also something the hydrotest tool essentially would allow you to do that. Now, few things here. So I'm going to start creating a new case to show you the workflow so that we can have a look at what the workflow looks like and what are the different steps involved. We will, if time permits, we'll come back to the existing case and go through the different sectioning, different aspects. What are the different input parameters as well as output parameters, see how the program is functioning based on different scenarios. Everything will be covered here. So if you are new to hydrotest planning, what you do is you create a new case by clicking on the create new. What it does is it brings up a pop-up. It asks you for what code standards are you doing your hydrotesting for. If the fluid that's flowing in the pipe is, in this case, I'm going to select gas to essentially say it's gas, so that the code standards are correspondingly adjusted based on that. Now, there is a pressure adjustment that you can essentially do for the contractor. If that is something that you want to include, you can essentially define what is the pressure adjustment that you want to include there, and also the buffer pressure. So once you're done with that, the next step is essentially selecting what is the workflow that you would like to follow to essentially do your hydrotest planning. There are 3 different options, as you can see here. Manual is where you are defining all the input data manually, one field after the other. So if that's a workflow that you want to follow through, we have the capability to do that. If select pipe is a selection that you're defining, what it does is, since our tools are fully integrated with maps and hierarchy, you can, if you have an asset data that you want to bring it in, we have the ability to bring the particular asset data through the map feature, that's the S3 map, or the hierarchy feature that you see on the left, and bring that pipe. Thirdly, if you have a reference or a survey file that you have that you would like to essentially bring it and govern your sectioning based on that, you can essentially bring that. So for us, so in this case, I'm going to select survey data to show you the survey capability here. So I selected the survey. The next step is basically giving you a prompt to say, okay, fine, bring in your survey file. And this is where I'm selecting the survey file here. The survey files usually is a standard template. This is what a survey file looks like. So it has send line, it has your pipe configurations and your operating configuration, the begin station and end station, and also the lat longs that are tied to the particular locations of the pipe where the survey is done. So it has most of the fields that are really critical and essentially defining your hydrotest plans. So if you have a survey file or survey data, you can use our template to essentially pre-populate your survey file with the data. Gray fields that are grayed out are automatically calculated, so you don't have to fill in. It's basically picking up data from begin station and end station to calculate the length of the segments and the milepost data for you. So in this case, I'm going to bring the same survey file to show you essentially how easy it is to bring in the survey data. So here, what I do is I browse the file, I select the survey data or the survey file. Now, as I'm bringing in the survey file, you saw the different fields that were pre-populated. So now, as part of doing the semi-automation workflow process, one of the things that we do is we allow you to essentially define your rules as to how you want to define the sectioning, if you want to go that route. In this case, I mean, you can essentially define your sections based on what those governing parameters is. I mean, if reclassification or reaffirmation of MAOP has to be done based on the location class. In this case, I would like to do that to see that. I select class locations, and what the model essentially does is it's looking at locations where the location classes class locations have changed and break those sections based on that. And that is something that the model does. And now when I click next, what it does is it's automatically creating those sections based on where the locations have changed. And these are the lat long locations that came in from the survey file, and that gets populated in the map so that you see where these locations are. So that's a easy workflow within the survey data that's there. So so there are different avenues for you to actually choose from what works best for you. Now we'll go back to our existing case so that we can work more from the existing case. So this is our existing case that I showed you. Here, let's look at what are the data that's required, what are being covered in the input and the results, right? So here, what you see is, I mean, it's an intuitive workflow. So for each individual section, you have the input data and the result sections that are two separate tabs there. So on the left, you see the pipe configurations. The pipe essentially configurations are populated on the left side. So if these are common data fields that are coming in, like let's say when I brought in a survey file, if I have those common data fields, that gets pre-populated there so that I don't have to redo that work of manually entering it. If I'm bringing in an asset, that's also a place where I can pre-populate this data if the asset data carries those configurational data that's there. Now, what you also see here is the elevation profile data that's coming in, and also the operational parameter data that's there. So we have the MAOP, whether, I mean, if it's a previously MAOP established section that we are redefining, we can essentially use the MAOP established to essentially test your hydrotest plan for that particular section against that. What it also has is these are features within the GIS system. So one is simply bringing in or allowing you to bring in your file from a hierarchy or a map, if that's the way you choose. What we also have is the capability to bring in the elevation for you, basically based on the begin station and end station for an asset that's already in the system. So if in this case, what I have done is I have used what we call as the 3D analyst tool. That's a 3D analyst tool within the GIS system to bring in my ground elevation for the section based on the begin station and end station that are being defined here. What it also does is it's essentially giving me or fetching me what my low elevation and high elevation are for those particular locations. They automatically fetches all that. And so in a way, it's essentially helping me semi-automate my workflow and also ask me those relevant additional fields that are required that are missing in the data flow. So whatever your use cases are, there are ways we can essentially make it function within the workflow here. What you see under the result is the section, the result calculations based on the data input that's there. You might have seen 3 sections here. This result section is specifically tied to the hydro test that we did for that particular section. What we are also doing is a lot of you might be familiar with the pipeline toolbox. Under pipeline toolbox, if you go into pipeline testing, there are additional calculations like the pipeline hydrostatic testing and the MAOP calculations that are being done in the pipeline testing module. We use the same inputs that are being pre-filled for each individual section to run those calculations too. There are times when it is relevant to essentially pick up those data if those are the scenarios where you want to essentially see the compressibility and those kind of hydrostatic testing analysis that thermal change and the volumetric change, those kind of fields that you normally go to pipeline toolbox to do that. Those are also duplicated here so that you don't have to do it in multiple ways. You can just do it here. And on the right is where you see your minimum and the maximum test pressure for the sections that you have done the testing and the adjustments that are made based on the threshold configuration that you have made at the top level here, at threshold level. Now, for places where the validation checks are producing the validations for you to look closely into, what you see is a warning section that essentially gives you a context on why the warning exists. We have our help documentation that covers the different reasons why those validation checks comes in and what are the ways what are the places or what are the ways, I mean, you can essentially control those validation checks and mitigate it. So that is in our documentations here. So if you are seeing those warning messages and want to know what are the trigger points that are essentially causing it, that's in our documentation piece that's covered there. And finally, what we also have here is the final cumulative report that can be generated here. So once you have done your analysis, once you have the data for each individual fields, you've completed your hydro test planning, you are good to go. And if you have that level of confidence, the next thing that you want to do is you want to generate a full-blown report for the hydro test planning so that it can be handed over to the next group that's executing the handoff. So if there is any specific notifications or notes that you want to add for each individual section from a high level, you can actually have the notes captured here. But let's say, I mean, if you have notes or notifications that you want to capture for each individual section on what that specification is, there's a comment section for each section that can essentially be the place where you can capture the comments for each individual section as to what you want to communicate to the contractor. If that's there, you can do that. Now, I want to spend a little bit of time looking at what the report looks like. So here is the hydro test report for the base case that I showed. What you see here is a report that's a full-blown report that has the ArcGIS snapshot and the elevation profile for each individual section. So when you go, this is the summary tab data that you have here for the different sections that we created. Now, for each individual section as you're going in, it highlights that particular section that you're looking at, what the elevation profile for that particular section is, and you also have the hydro test input and the results. I have used the MAOP established as the governing factor to essentially run this, and that's the reason why, I mean, it's showing MAOP established as the factor there. And you have what we call as the begin station and end station and all the data that's required for the team to successfully execute the plan. That's all available here. What it also has is the results that are coming in from the hydro test for the maximum and minimum test pressure and whatever that you want to communicate to the contractor based on the adjustment that's also captured here. What it has is also the supporting calculations that we covered as part of pipeline toolbox calculations underneath that. Now, for sections that are failing or that have warnings there, it also brings in that warning messages for you. So in this case, section 3 had that warning or an error message that was there, and that is captured here as part of the report too. So this is also subsequently captured and analyzed here. And this is what the report looks like for all the sections and all the profiles that you have here. And again, the way to essentially do the reports is when you click on the report, run report, it comes up with a pop-up. If you have elevation profile and the ArcGIS map integration or an option there, these additional smart features comes in. If not, I mean, you can still go by your regular Hydrotest planning report that actually has the lat long and the features that are coming in there. So that is also something that's an additional level of configuration that's there within the tool. Now, within the mapping tool, if you would like to essentially split the screen, look at the screen based on both map and the elevation profile, that's also something that can be done. If you want to look closely into that particular sectioning, that's something that that we can do with the map feature that's there. If lat long, additionally, I mean, if begin station and end station has to be defined through the geologs or the lat longs, you can essentially use the point drop feature to drop pins for the begin and end station for each individual section to essentially do that. So that is also something that we do that within the Hydrotest Power tool. Also, in addition to that, there are a lot of validation checks that we have done to make sure your data is properly validated as part of you defining your section configuration and your workflow. So, for example, if there is a significant difference between your begin station and end station, so the model automatically triggers it in the overview section to essentially give you an overview that, hey, there's a difference between the end station of the first section and the begin station for the next station. It's not preventing you from running the calculation, but it's giving you the validation checks in an intuitive way so that you as an engineer can have a better overview on the different analysis that's being performed there. Additionally, we have different warning signs here. So if there are any places where we see a warning is existing in the section, or if the section needs additional review at your end, I mean, it brings in a color-coded warning there. If there are input data that you missed or that's not populated, that also brings in a validation checks for you to essentially look at it. So those are some nifty validation or intuitive UI features that have been introduced within the Power Tool software. I hope the demo was intuitive enough to capture the full essence of what we have done with Hydrotest. What we are going to do now is going back to the presentation so that we can take you to the subsequent slides. It's mostly questions that it's mostly around questions that we can ask, and I think there are some poll questions too. So I'll take you back to the presentation now next.
Perfect. Thank you, Febin. So we do have a couple poll questions that we're going to display for you. We're always looking at ways to improve here at Technical Toolboxes. So these help us gauge your interest in the Hydrotest Power Tool and kind of guide us in our next steps. We'll put up each of these questions for about a minute each. Then we can move on to the Q&A. It does look like we got some great questions in, so we want to cover as many of those as possible. If we don't cover your question during the webinar live, we will follow up via email, but hopefully we'll be able to cover most of these. So you should see the first poll question up now. For Febin and Joe, we do have some questions I think you can cover without needing the screen. How many sections can the tool handle? I saw that you showed 6 in your demo.
That's a good question. The tool can handle up to 50 sessions right now.
Perfect. We should have the second poll question coming up here. There we go. And then another question we got is, what formats are available for the report that you can export?
So the report format right now, we do allow export, we do allow PDF reports, and also if you want, you can also export the report or the data in an Excel format if that's also something that's interested.
Great, thank you, Febin. Just a little longer on this poll question, and then we'll move on to some of the other Q&A questions. Okay, so moving on to the Q&A, let's start with, can the tool help in accepting an ongoing run with changes in temperature and pressure to determine the volume changes?
Joe, you want to take that question, Joe? I think it relies more on your expertise on that front.
One of the things we have is in the results, you'll notice that we take things to the third and fifth polynomial, and if there's any change, and the reason we did that is because of the possible changes that could occur, for the accuracy of whether you're having a leak or is it just a true temperature change that's causing the pressure to increase or decrease. So you have that capability to get that additional accuracy, and we developed that those polynomials for that purpose. Thank you.
Thanks, Joe. Next question, can you import CAD files or files with pipe profile and elevation?
So we can import the data in an Excel file format right now from the for the pipe profile and the elevation profile. We don't do CAD integration right now within the Hydrotest.
Okay, and what is the maximum length for each section?
There are a lot of governing factors that's there, right? So I mean, if you, from an elevation standpoint, if your elevation isn't, if your elevation head isn't really high, I mean, you can create sections that are longer compared to how it would have been, I mean, if you have an elevation difference. But when we say maximum length defined, if you can, let's put it this way, I mean, if you want to essentially take a particular pipe and do the Hydrotest with just one section in, that's also possible within the Hydrotest Power Tool.
Awesome, thank you. Let's see, next question here. The tool seems to be focused on planning the test. Is there capability to review data and approve it based on actual results during the test?
This is a Hydrotest design tool, design and planning tool. So it's essentially allowing you to plan and essentially help you generate the test plan. So the approval process is not something that the tool does, because it essentially is executed in the field and you're taking the data back to complete the approval process. So that documentation piece is not something that we are handling within the tool.
Okay, and can the tool calculate the maximum hydraulic pressure according to the elevation profile?
Yes, it can essentially take the elevation head into account and calculate that.
Great. Here we go. Next question. Can you change the test media type to air or nitrogen?
Joe, I mean, I think this is a question
Yeah.
more on pneumatic testing.
Exactly. It's pneumatic testing, and again, this is a hydrostatic tool. We are looking at nitrogen and air, gases, or And at this point in time, they're more based on, it appears, just looking for leaks. They're short term, but generally they're short term. So at this point in time, we're still reviewing that.
Thank you, Joe. Here's a good one. Does Technical Toolboxes have an app for more metal loss issues and pig runs?
Regarding metal loss in pig runs, we do have the R-string program set up to do batch runs where you could run 50 50 different calculations at the same time. So if that's what you're referring to, yes, we've addressed that issue when you're dealing with issues that are related to R-string. Now, keep in mind, that's when we're talking about R-string, that's a level 2 evaluation as compared to ASME B30, the B31s, the original and the modified. Those calculations are level 1s, and all they're doing is taking the maximum depth and the maximum length, and that's done, by the pig vendor. So we could repeat that. There's no reason to do it, but that could be done. But everything we're focused on is R-string level 2 calculations.
Thank you, Joe. Here's another good one. What's the test duration? How about the leak test and the stress test?
So depends on, so for the right now, I mean, the example case that I showed was a full-blown hydrostatic testing, and you usually do the testing for 8 hours based on the CFR 192 or 195 recommendations. Joe, do you want to take that second part of that question on leak test and the stress test?
Yeah, if you're referring to spike testing and things of this nature where, the minimum test starts at 15 minutes up to whatever you want to keep it. At this time, we're reviewing how to set that up, and for particularly outside. And here's a perfect example: test duration, depending on the cracks that you're dealing with. Most cracks, like I say, the regulators are looking about a 15-minute test. Most pipeline operators do a 30-minute test, and others do around a 2-hour test. So actually, I'm giving a paper at NACE on this, and these are, and there's reason for some of this is because of the type of failures and cracking that you're seeing on your pipeline. So again, this is something we could work with you on that and set that up accordingly. And that's strictly under review. And please contact us so we could work together on that, to address your specific issues.
Great, thank you, Joe. Let's see here. Next question. Does your tool have the capability to do above ground hydro testing?
Yes, we can. The only caveat there is you are essentially defining those begin station, end station, and the min and maximum elevation from a above ground specification at that point. And as long as you're defining it the right way, the tool should be able to handle that.
Well, there's another consideration is the temperature. If you got a sunny day and the pipe is above ground, that's going to present some problems. Normally, we try to most of our testing is for underground for reasons to maintain the stability, after the water's in the system, and that usually takes up to 48 hours. And anytime you expose the pipe, you're going to subject it to increase sunlight or maybe ambient temperatures and things of this nature that could impact it. So it's not just the UV that's the problem. It could be cold temperatures. So they're going to create some fluctuations.
Also, just to add to what Joe said, I mean, the thermodynamic model, there should be currently we don't have that, but there should be a little bit more complex thermodynamic model that needs to be in place, because when you are exposed, there is a variation in temperature ranges for the fluid that you are dealing with, and that can take into account on the expansion and compression of the fluid, and those impacts has to be studied and evaluated as part of your hydrotest planning. But good question there.
Thank you both. I'm going to start kind of wrapping up, but I'm going to try to get one or two more questions in here. Can the tool do pressure volume plots?
Good session, Sophia. We don't currently do it, but something that we can definitely take upon. It's the feedback like this. I mean, that's important for us. And please feel free to work with us on that front. We can officially reach out to you on what your specifications are. We wanted to just put something out there so that we see, I mean, how our clients are liking it. If you feel like, I mean, that's one thing that has to be implemented, we definitely can look into it.
Okay, and then let's hit this last one before we close out. You used an onshore example of the pipe locations. Is it possible in the same way to use it for offshore, considering, you know, the deep pressures, temperatures, etc.?
It is possible, but that's something we have not addressed at this point in time.
Thanks, Joe. And one last question here. Any recommended diameters where hydrotest is not recommended?
I think a way to look at that would be what we have presented from a hydrotesting standpoint is for the transmission lines. For distribution lines, I mean, where the pressure difference is significantly lower and the length of the pipe is lower, you don't necessarily have to do hydrotest. You can even do pneumatic testing. But
yeah,
I think the question more so was around the best practices of what the diameter looks like for a transmission line. I mean, if it's a transmission line, you normally get to know from an industry-wide survey on what the normal diameters that you normally interact with, and for those diameters, the tool is sufficiently capable of handling those. Joe, anything to add there?
Yeah. Do you hear me?
Yeah, I was asking, is there anything that I missed that you want to add?
Oh, I'm sorry. Yeah. No, that's a great response. And again, I was mentioning TVC requirements, and that's another thing that I know you guys have asked, and let us know how you're doing it so we could fit it into the program.
Thank you, Joe. Thank you, Febin. Thank you all for submitting questions. For those that we didn't get to address, we'll follow up via email. Thank you both to Febin and Joe for the presentation, and for everyone in attendance. You will receive a copy of this recording via email in the next 24 hours. If you have any additional questions or interest in the tool, please reach out to us at Technical Toolboxes. Here is Febin and Joe's direct email address, as well as our website and our a marketing team email that you can reach out to if you have any questions. Thank you again, and have a great day.
Thank you.
Thanks, everyone.